Good day, everyone. Welcome to That Friendly Writer Statistics and Data Analysis tutorial videos for TBL students. This is my YouTube channel where you can watch lots of statistics and data analysis videos. Today, we'll learn about applying the central limit theorem in using the formula z equals the square root of n times x bar minus mu, all over sigma. Alright, let's get started. Let's have an example. A normal population has a mean mu equals 20 and a standard deviation of sigma equals 5. A random sample of size n equals 9 was taken, and we observed that the sample mean x bar is 23. How rare is getting such a sample mean? First, we list our new formula. Z equals the square root of n times x bar minus mu divided by sigma. We are ready to plug in the values from our given. Sample size of 9 goes inside the square root. 23 is put for sample mean x bar. 20 is put for population mean mu. Take note not to interchange x bar and mu. Sigma is replaced by 5. We subtract the estimate by the true mean, so 23 minus 20 is 3. Get the square root of 9. This is equal to 3. We can take a look at the table at the right to see why the square root of 9 is 3. Using the two results, we multiply them now. 3 times 3 is 9. We shall be dividing by sigma, which is 5, and the answer is 1.8. This is the z-score of the sample mean. Since we are assuming that the sampling distribution of the sample mean is normally distributed, we can sketch z equals 1.8 out on the normal curve. Now, which do we shade? The left or the right area? We shade the one which has a lower chance of occurring. In this case, we shade the right or upper tail. Therefore, the area to the right of z equals 1.8 is 0.0359 or 3.59%. What does this mean? We expect a population mean of 20, but we ended up with a sample mean of 23. Getting a sample mean, or as extreme as this one, occurs only 3% of the time. Therefore, this is quite a rare occurrence. In our language, we will refer to this as the p-value of the sample mean. Here's another example. Body mass index of senior high school students has a mean mu equals 21 and a standard deviation sigma equals 4. We don't know this distribution, so we use a large random sample of size n equals 31 to be safe. We find out that the sample mean is x bar equals 20. How rare is this sample mean? We use our formula, z equals the square root of n times sample mean minus population mean divided by sigma. Plug in 36 for n inside the square root, 20 for x bar, 21 for mu, and 4 for sigma. Subtracting 20 and 21 is negative 1. Do not interchange them, x bar and mu. X bar comes first before mu. Then the square root of 36 is 6 because 6 times 6 is 36. Multiply the two results. 6 times negative 1 equals negative 6. Divide this by the sigma of 4, and negative 6 divided by 4 finally equals negative 1.5. We sketch this as a bell curve. Negative 1.5 means we exceed 1 but not yet 2 on the negative side. Shade the left side since we are after the extreme values. And the probability is 0.0668 or 6.68%. This is the p-value of the sample mean statistic, x bar. This means that this is the probability of getting a sample mean of 20 or even lower when we are expecting a mean of 21 all along. This is the application of the central limit theorem. Now, for our practice, calculate the z-score of the sample mean. Afterwards, determine the tail probability or p-value of the computed statistic. Remember to choose and shade the smaller probability. A calculator may help you, especially in the second problem. In finding the p-value, you will need to use the app to give the area to the left or right, depending which is smaller between the two. Alright, this concludes our video for today. Hope you learned something new, and have a friendly day!